Okay, so here we go with GCF, greatest common factor. The definition here is the highest number or expression that divides into two or more numbers or expressions. Some specific steps to find the GCF. This is the method that we teach. There's obviously other methods, so if you have something that works better for you, by all means, you do what works best. But what we're going to do here is we're first going to find the prime factorization of each number or expression. Okay, once we've done that, we're going to circle all the common prime factors, and that's a little pitfall we'll talk about later between the two numbers or expressions. And finally, we're going to write the product of the common factors and simplify. So what's that going to look like in practice? Well, here's the first example. Find the GCF of 36 and 194. Don't be alarmed by the larger numbers. Use your basic division rules to help make them smaller. But if I was doing the prime factorization of 36, I would end up with 2 times 3 times 2 times 3. And then 194, that's a large number, but I know I can divide it by 2 because of the even number, the fact that it's an even number. All right. And when I do that, I'm going to end up with, let's see, what is that going to be? 97? Okay. And now 97, that's a tricky one. I'm going to have to check that. Is that a prime number? Can that be divided? And the easiest or quickest way to do that is just take out your calculator, okay? And rather than sit there and just stew over it and use sit and stare method, if you have a calculator readily available, use the calculator, okay? There's nothing wrong with that. Take the number 97, check it for, it's not even, so it's not divisible by 2. So check it for some easier ones like 3. No, not divisible by 3. It's not divisible by 5 because it doesn't end in 5 or 0. Maybe 6. Okay, doesn't look like it. Whoops. Let's see here. This calculator doesn't work. All right. So what about? Okay, Mr. Worm. 97. Can't imagine it's divisible by 7. Nope. All right. So I'm pretty sure 97 is prime. Okay. Again, guess and check method is always the best way when you're stuck like that. All right, to determine if it is or not. So, what's the GCF? Okay. Well, I've prime factorized both of them. I'm going to circle the common prime factors. Well, in this case, the only common prime factor between the two numbers is the number 2. So the GCF of example 1 is just 2. Now, if there would be more common prime factors, I would write them all out here and then multiply them together. And we'll see what that looks like in example 2. Start with the numbers. Process is the same, even though there's letters now. That's no big deal. So 9 and 2 for 18, 3 and 3 for 9. Those are all prime numbers. The nice thing about the letters is that x squared is just xx. The exponent is nothing more than an indicator of how many of those letters that you have. So y cubed will be y. For 48, okay, I'm going to split that up. Again, it's an even number, so you can use 2 if you want. That would be 2 and 24. Okay, then the 24, again, however you like, 2 and 12. 12, 3 and 4. And then the 4 here would be 2 and 2. So there's a little bit of work there for the 48. X cubed is xxx. And then y is y. Now, I want to go back through and circle all my common prime factors. So when I look at this, I have a 3 on this side, and I have a 3 on this side. Okay? I have a 2 on this side, and a 2 on this side. Numbers-wise, that's it. Yeah, I have a 3 over here, but there's no more 3s on this side. Okay, and I have 3 more 2s over here, but there's no more 2s on this side. So I'm finished there. I can't go any further. Now, what about common x's? Looks to me like I have 2 x's on this side and 2 on this side, and there has to be the same number on both. As far as y's go, I have 1 here, and I can take one of those. And then the last step is to write out what pairs I have. So I have a 3, I have a pair of 2s, I have 2 pairs of x's, and I have a pair of y's. And then simplify that expression. So 3 times 2 would be 6, so the GCF here would be 6 x squared and y. Let's try one more example. I'm actually, if you would mind pausing it and solving this one on your own, and then check back and see what the answer is. The only difference now is there are 3, So when you're looking for common factors, you have to have a common factor in all three of them for it to be the GCF. Go ahead and push pause. All right, so I'm going to take a look at that. There's your work. Go ahead and check what you did against what I did. But what I ended up finding in the end is that there was a 2 and a 3 in each of them. No other numbers were in common among all three. There was a pair of x's in each. Okay, so a pair of x's here, a pair of x's here, a pair of x's here. There was only one y in each. Okay. Yeah, these two had two y's, but remember, all three of them have to have them. And even though these two had z's, and this one had z's, this one had no z's, therefore there's no z's in common among all three expressions. So in the end, then there was a 2, a 3, an x, and a y, which gave me 6x squared y. That's GCF.